Greetings. This is Mr. Glenn of ACT Prep Chicago. Um, this is our website, just in case you want to contact us. Um, you need any more assistance or help on any of the um, prep material or test prep or one-on-one tutoring, ACT Prep Chicago yahoo.com is the email. That's your phone number. And the address has changed. We got to change that address. But anyway, we're here to review the preparing for the ACT. Um, Second part for the science is the ACT Practice Test 2 from the ACT's official website, which is here. Um, so I got this test here from ACT's website. They have online practice test and sample questions. This is ACT Practice Test 2 PDF. I believe it's the same exact questions as the online digital version. This is the new enhanced version of the test. Which it would be here. So this would be practice test 2. You could do time to time. Science is what we're working on. So if you took it online digitally, it would be here. And then they would load it up for you. I think, did we do time on time? I can't remember. Oh, I did the time one, but I didn't have to. Okay, yeah. So yeah, these are the same questions we went over yesterday. So yeah, so this is the digital version. Um, of what we've been working on. Um, this is the Digiverse. So if you want to get to this web page and you click, and I think these links are going to be in the description of this video. You could get it that way. Um, or if you want just a PDF version of it, you didn't want to take it online, you just want to do PDF version, you will click here and it will give you this. And we're on test 2. We're doing test 2. All right, so we did part 1 of the science in a separate video. Let's finish the science, part 2. Um, One thing I noticed is that it looks like it's 2 conflicting viewpoints passages. It used to only be 1 because we did 1 with passage 2. Conflicting viewpoint passages are they're like reading passages within the science section. So you won't see charts, graphs. Um, you won't see charts, graphs, tables. You would just see words. So you just like I said, a reading section within the no, a science test within the I'm a reading test with a reading passage within the science test. So this is one we did the first week. You see it's no tables, charts, or graphs. And the next one, and we already did these questions, not the first week, the first session. Now we're doing this starting with 24, and this is another conflicting viewpoints. How did I know? Well, it's a diagram, but it's no tables, charts, and graphs. And then it says student 1, student 2, student 3, and student 4, right? So these are these students' opinion about some kind of phenomenon that they're starting with, that they're naming initially. Um, so let's see. So with these sections, I like to read first. I don't know why it's doing that. My mouse pad not working as well. Anyway, with these sections, I like to read first. Okay, so and get just a general idea. Again, it's an open book test, so you don't have to memorize or remember all the details, but you want to get a general gist of overall everything that's happened. Okay, so the introduction. The teacher performed a demonstration on forces. She placed a beaker on a digital scale and added water until the combination, I'm sorry. So a teacher performed a demonstration on forces. She placed a beaker on a digital scale and added water until the combined weight, the force of gravity on an object of the beaker and water was 10 newtons. And I think they're probably showing you that in the diagram below too. Yeah, so 10 newtons there. Yeah, 10 newtons. Something that's not right. I might have to start this over. This should be working this badly. 10 newtons. She then covered the display panel and held a solid steel rod at rest, partially submerged in water, such that she then covered the display panel, or she covered it up, this display panel, and held a solid steel rod at rest there, partially submerged in water such that it was not in contact with the beaker. So it wasn't leaning on the beaker. She held this solid steel rod above the beaker, inside the water, but it wasn't touching any of the beaker. Well, why would she cover up the scale with a digital reading? The teacher then asked her students, the rod has a weight of 5 newtons. How much of that weight is supported by my hand, and how much force is exerted on the scale? 4 students responded. Student 1, the rod displaces some water, producing 2 simultaneous effects. An upward buoyant force, B, is exerted on the rod, regardless of the rod's density. B is equal in magnitude to the weight of the water that is displaced. The depth of the water increases, which causes the water pressure at the bottom of the beaker to increase. As a result, a downward force equal to magnitude to B is exerted on the bottom of the beaker. Therefore, the teacher's hand is supporting a weight equal to 5 newtons minus B, and the force exerted on the scale is equal to 10 newtons plus B. All right. And then, do this one. It's not working well with the scroll down. So what was the teacher asking? How much force is exerted on the scale? The student want to answer how much is exerted on the scale? Therefore, the teacher's hand is supporting a weight equal to 5 newtons minus B, and the force exerted on the scale is equal to 10 newtons. We already knew that. How much force is there on the scale? Is it 10? She's saying 10 additional, or she's saying just the original 10? Because I guess she's saying that the teacher's hand is supporting a weight of equal to 5. So that the students, it looks like student 1 is saying that the the um the teacher's hand is holding all the weight of the rod. Therefore, even though the rod is in water and it displaces some water, wait, upper force is exerted on the rod regardless of the depth of the water increases, which causes the water pressure at the bottom of the beaker. As a result, downward force of equal magnitude be exerted on the bottom of the beaker. So she's saying it is a downward force, and the downward force equal in magnitude to B. So therefore, the teacher's hand is supporting a weight equal to 5 newtons. So the teacher's hand supporting it, does that mean it's not on the, but they said the equal in magnitudes are on the bottom of the beaker. Okay, let me just maybe read the other, and I'll get a better idea. All right, student 1 is correct that B is exerted on the rod and the water depth increases. However, the depth has no effect on water pressure. Therefore, the teacher's hand is supporting a weight equal to 5, and the force exerted on the scale is 10. So they're basically saying the same thing, but just they're talking about the pressure. Because it says teacher is supporting a weight of 5, and the force exerted on the scale is equal to 10. Student 2 says the same thing. Teacher's hand is supporting a weight of 5, and the force exerted on the scale is 10. All right, student 1 is correct that B is exerted on the rod and that water depth increases. However, the rod is less dense than water. So B is equal in magnitude to the weight of the rod. However, student 2 is correct that the depth has no effect on water pressure. Therefore, the teacher's hand is supporting 0 newtons and the force exerted on the scale is 15. All right, so this one is saying that the weight of the rod, I guess, which is that for 5 newtons? Yeah, 5 newtons. So we get it. So that's why you read them all. So student 1, student 2 says the teacher's hand is supporting the 5 newtons and not going on the scale. Student 1 and 2 says. Student 3 says the student's hand is not supporting the rod, right? And therefore all the way is going on the scale. Student 1 is correct that the water depth increases. However, the rod is denser than water, so B is 0. Further, student 2 is correct that the depth has no effect on water pressure. Therefore, the teacher's hand is supporting 5 newtons and the force is set on the scale is 10. So in terms of the reading on the scale, student 1, 2, 3, and student 4 would all say that this blank one would have a reading of 10 still, because the hand would be, student 3 would say this scale would have a reading of 15. That's the only student that would have say that the scale would have a different reading. The other ones say that the hand is supporting the steel rod, and therefore that weight would not transfer to the scale. But they all disagree about something. So, all right, we don't need to study it too. We just need to get overall just what's happening. Okay, which student would be most likely to agree that while the rod was partially submerged, the scale was supporting the entire weight of the rod? We just said that's only student 3, because student 3 said that the exerted the weight, therefore the teacher's hand is supporting 0 newtons, and the force exerted on the weight is 15, which would be the weight of the beaker and water, which is 10, plus the 5 Newton weight of the rod. Okay, which would mean that what? The scale is supporting the entire weight of the rod. All right, 25. So the answer 24 is student 3. 25. Within a fluid, pressure increases as depth increases. So that means as you go down, the pressure increases. This fact weakens the response given by which students? I know it's as pressure increases, depth increases. Pressure increases, depth increases. So the farther you go down, the greater your pressure. Where they talk about pressure here is the water. The depth of the water increases, which causes the water pressure at the bottom of the beaker to increase. That would weaken student 1. See, because student 1 says the depth of the water, as you go further down, the water pressure at the bottom of the beaker increases. But this says water pressure increases. Oh, no, this is saying the same thing. Pressure increases as depth increases. Further you go down, the more pressure. So it would not weaken student 1 because student 1 said the same thing. So we could get rid of A and B. So it's either 3 and 4 or 2, 3, and 4. Let's look at 2 because that will give us the answer actually. What did 2 say? Because if it weakens 2, oops, if it weakens 2, because we know it's not student 1, so A and B are out. So what's the difference between C and D? Is student 2. So if it weakens student 2, then we know it's C. If it doesn't weaken student 2, then we know it's D. What does student 2 say about water pressure? What? That B is exerted on the rod and that water depth increases. However, depth has no effect on water pressure. So if that's what student 2 is saying, then it would not weaken, it would weaken student 2's response because this says pressure increases, depth increases. Student 2 says it has no effect on it, has to be D. And I think they all said that. Student 3 and student 4, they said as um, depth has no effect on water pressure. Student 3 says it. Student 4 says depth has no effect on water pressure. So student 2, 3, and 4 says depth has no effect on water pressure. The question says as pressure increases, depth increases. So that would weaken 2, 3, and 4. So the answer is D because that disagrees with what 2, 3, and 4 are saying. All right. Suppose that it were determined that the magnitude of B was 1.37 newtons. All right, the magnitude of B was 1.37 newtons. What is B? Based on the student's truth argument, how much weight would the teacher's hand have been supporting? What is B? I think it'd be 6.37 as I think about it because it's the student's hand. Oh, I see what's up. My hands are full. Um, what determined B? I think it's going to be 6.37 because the teacher's hand was already supporting the 5 Newton weight. We know student two said that. And then also you add the magnitude of B was 1.37. The teacher's hand also supported B. However, depth has no effect. Therefore, the teacher's hand is supporting a weight equal to 5B, right? But we had to add that to the what? To the five, the rod that it's holding as well. So the teacher's hand would be supporting the weight, which is 5 Newtons, plus the 1.37 Newton, right? So you do 5 plus 1.37, that's how to get 6.37 J. Let me make sure that's correct. That's 26. Oh no, they're saying 26 is G. I think they're saying too, I think I got it. I think they're saying that they will replace it. So the five, it wouldn't be, the B would not be 5 anymore. B would just be 1.37. They subtracted how much weight would the student's hand have supporting? Determine the dimension of B. What is B? I should figure out B. Student B, that B is exerted on the rod and that water depth increases. An upper buoyant force B. Oh, I got it. So, so this is what they're saying with this one. They're saying that basically the teacher's hand is holding the 5 Newton steel rod, but B is a buoyant force that pushes against the whatever is in the water. In this case, the rod, right? Buoyancy means makes things float, right? And it's an upper buoyant force. So that's pushing against the rod that you're putting in the water. So because the buoyant force would be going upward, right, against the steel rod that's being put in the water, those are opposing forces. So 5 is what the teacher's holding going down into the water. That's 5, that's a force of 5 going down. The buoyant is pushing back against that 1.37. So you subtract the 2 because really what the buoyant is doing is it's allowing the object to appear lighter than it actually is. Because the buoyant force is holding up part of the weight, the buoyant force of the water. And so that the teacher doesn't have to hold as much weight. So that's why it's 5 minus the 1.37, which will give you, if you did the math on that, you would get 3.63. I would not have gotten that on the test, but that's okay. Now I can think about these kind of questions in that way. All right, 27. Suppose that the teacher had held the rod above the water, so not in the water, but above the water, such that no portion of the rod was ever submerged. Based on student one's response, how much weight would the teacher's hand have been supporting? It would have been supporting 0. Oh no, it would have been supporting 5. The teacher would have been supporting the entire weight of the rod because the buoyancy force would have been, no, the buoyancy would not have been 5. The teacher's hand would have supported the entire weight of the rod because the buoyant force would have been 0. It's D. If it's not in the water, there's no buoyant force. Buoyant force comes when you put things in water, put something in a liquid, it pushes back, right? But if they said that the question said the teacher held the rod above the water, so it said no portion of the water was ever submerged, meaning the rod was never put in the water, you have no buoyancy force, right? So how much weight would the teacher's hand have been supporting? It would have been supporting the whole 5 Newton um rod, which would have been D, because it wouldn't have had any, and because the buoyant force would have been zero. Buoyant force is created when you put things in fluids, right? So 27 should be D. I'll check that just to make sure. I'm pretty sure about that. Yeah, 27 is D. Yeah. Okay. 28. In regard to B, which of the following statements summarize responses given by students 1 and 3? Student 1 claimed that B is equal in magnitude to the weight of the displaced water, whereas student B claimed that B is equal in magnitude to the weight of the rod. Students 1 and 3 both claim that B is equal in magnitude to the weight of the displaced water. Student 1 and 3 both claim that B is equal to magnitude to the weight of the rod. Is J. 1 and 3 claim that B is equal to the weight of the rod. It's just a matter of, right? Because it says, therefore, teacher hand supporting a weight equal to 5 newtons B, right? Or minus B and plus B, right? In regard to B, which of the following statements summarize the response given by student 1 to student 1 claims that B is equal to magnitude to the weight of the displaced water. Student 1 claims that B is equal in magnitude to the weight of the rod. And that before B is exerted on the rod, regardless of the rod's density. B is equal in magnitude to the weight of the water that is displaced. Right. As a result, a downward force equal to magnitude to B is exerted on the bottom of the B. Therefore, the teacher's hand is supporting a weight equal to 5 newtons negative B. Forces on the scale is equal to 10 newtons positive B. And then student 3 says student 1 is correct that B is exerted on the rod and that the water depth increases. However, the rod less dense than water, so B is equal in magnitude to the weight of the rod. So it says B is equal in magnitude to the weight of the rod. B is equal in magnitude to the weight of the rod. That's what student 3 says. So that being the case, that should be which of the following statements. Student 3 claimed that B is equal in magnitude to the weight of the rod. So we know it's F, it's possibility. Student 3 did not claim it's equal in weight of the weight of displaced water. What did student 1 say? Did student 1 say that B is equal in magnitude to the weight of the displaced water or to the weight of the rod? We know student 3 said it was equal in magnitude to the weight of the rod. The rod displaces some water, producing two substances. An upward buoyant force B is exerted on the rod, regardless of the rod's density. B is equal in magnitude to the weight of the water that is displaced. I said it right here. So B is equal in magnitude to the weight of the water displaced. Okay, so yeah, they're opposite. So I was wrong initially. So it's F. Student 1 claimed that B is equal in magnitude to the weight of the water displaced. We just read that. Whereas student 3 claimed that B is equal in magnitude to the weight of the rod. We just read that. So 28 is F. 29. Consider the before portion of figure 1 and assume that the scale was on a lab bench. If the scale, so before portion of figure 1, and assume the scale was on a lab bench. If the scale itself had a weight of 48.80 newtons, what total force must the lab bench have been exerting on the underside of the scale? Well, we know at least 48.50, because if the scale is going down, we got to go against the scale. We know the water was 10, so it had to be at least 55.80, right? Because the weight of the scale plus the weight of the water, because the scale reading had 10 on it, and then the scale was 45. That meant the bench to support both the water with beaker and the scale. Water with beaker weighing 10, scale weighing 4580. The bench has to have an opposite force to support it. Otherwise, the scale would break through the bench because it wouldn't be strong enough to support it. So that has to be D. I'll check it just to make sure. Uh, yes, 29 is D. Very good. All right. We got 10 more to go. 10 more to go. Let's go 30. All right. So now we're going back to regular, well, I won't say regular, but chart and graph based questions where we don't have to read and understand first. We can go straight to the questions. How did I know that? Because if you look at this, you see this. I don't have to read all this because I see what? I see words, and then I see what? I see a table, right? So I know I'm gonna go straight to my questions. Not many words, big table. Great. All right. Well, the batch of jam prepared with 1.0 pectin Z by mass as storage time increased the TMA concentration. So we're looking for a batch of jam prepared with 1.0% pectin Z by mass. Pectin concentration by mass, 1.0 Z. That would be here, right? 1.0 Z. Now, what's the time frame? TMO concentration and storage time of what concentration time do they want? As storage time increased, the TMA did what? For Z 1.0. As storage time increased, you go from day to month, 3 months, 6 months, you go left to right. The TMA decreased. Went from 28, 25, 20 to 15. So that would be G decreased on. All right, 31. Suppose the scientists had also prepared a batch of jam using 0.5% pectin Y. Okay. 0.5% pectin Y. Pectin Y 0. Oh, it's not on there. Suppose. Whenever you see suppose, you know it's not on there. So we're talking about values between what? 0.3 and 0.7. 0.5 is right in the middle there, right? Because you go 0.2 plus 0.3 is 0.5. And if I subtract 0.7 minus the same 0.2, 0.5. So 0.5 is right in the middle of here. So I'm looking for values in the middle of all these values. Okay. So it's probably going to tell us the time frame too. Based on the results of the three experiments at a search time of 3 months, like I said, change will most likely have been. So at 3 months, we're looking for between those two. So 3 months is here. So we between 28 and 32, right? Because 0.5 is between 0.3 and 0.7. So we want between 28 and 32. I would even say 30. You can almost guess that, but it'd be C, between 20 and 32. 32, which of the following variables was not an independent variable in the experiment? Independent variables are those that you choose, right, to manipulate. And dependent variables are what you measure in the experiment, right? So whatever results you're getting that you're measuring, that's dependent. Whatever you set out for the initial parameters of the experiment, that's your independent. So you usually choose independent variables and you want to see how they affect dependent variables. That's typically what you're doing. So um, that being the case, um, let's see. So which one of these was not chosen was measured? TMA concentration, because when we see on the chart, they were trying to measure TMA concentration at a source time. That's what the data is collecting. That's your dependent variable. That's what you're collecting. So that's they said was not independent. It's TMH concentration H. All right, 33. The other ones were independent variables. Pectin concentration, you controlled that. You set that from the outset. Storage time, that's something you control. You set that parameter for the experiment. Type of pectin, you chose that. You set that. TMA concentration, you did not choose. That was what you measured after you had those chosen variables. So that's why TMA concentration is not independent, it's dependent. It's dependent because it's dependent on the other variables. Okay, 33. Suppose that the experiment had been repeated. You did it again, except that the jars, so another suppose, that means this value is probably not going to be here. The jars have been stored at 30 degrees Celsius. How does that compare to what they were initially stored at? What was the initial temperature? So they were initially stored at what? All jars were then placed in dark storage, they maintained at 20 degrees. So I was just looking for some degrees Celsius. So we say we're going to increase the temperature. So what is TMA? Antacids are substances that can protect against cellular damage. Over time, antacids break down faster when exposed to light or added heat. Oh, so blackberries are a good source of antacids such as total non-monomeric. Right, so they're going to decrease, right? The TMA is going to go down faster when you what? When you add heat or light. If we do the experiment at 30 degrees Celsius, we're increasing the heat. So that means TMA should reduce at a faster rate. Will the TMA concentrations in this new experiment more likely have been less than or greater than the corresponding TMA concentrations in table one? They would definitely be what? Less than. Why? Because they would be dwindling at a faster rate because you added heat. That's because that's A. Less, the TMA concentrations in newer experiment would have been less because more TMA would have broken down at the higher temperature. Exactly. A. All right. 34. Assume that in the recipe the scientists used 100 grams of jam was produced for every 70 grams of blackberries. So we need 70 grams of blackberries to make 100 grams of jam. If no TMA broke down as the jam was prepared, what mass of TMA would have been found in 100 grams of jam before the jars were placed in boiling water? In 100 grams of jam before the jars were placed in boiling water. If no TMA broke down as the jam was prepared. Also, and then you didn't lose any TMA. So what was the initial TMA? No, 100 gram of jam that was produced. Um, TMA concentration at storage time of 1 day. All right, it's about there. So I'm probably looking at there because it's only been stored 1 day. Pectin concentration by man. Why does it talk about pectin type X, Y, and Z? Scientists contained fresh blackberries and determined that the concentration made was 200 milligrams per 100 grams of blackberries. 9 batches of blackberry jam each use 1 of 3 types of pectin at 1 of 3 concentrations. So it says that scientists obtained fresh blackberries and determined that the concentration of TMA was 200 milligrams TMA per 100 grams of blackberries. So 100 grams of jam was produced for every 70 grams of blackberries. Um, if no TMA broke down 100, what mass of TMA would have been found in 100 grams of jam before? Well, it wouldn't be 200 because it wasn't 100 grams of blackberries. So for this question, you got to do you have to do a proportion, right? The proportion would be so for 70 grams of blackberries, we don't know how much TMA, but we know that what for 100 grams of blackberries, not jam, make sure you got it with blackberries, right? They said above 100 grams of blackberries give us what 200 grams of uh TMA. So we can kind of look at that and tell it's going to be 140 because if it's 100 grams of blackberries, whoops, let's put that over there. This if it's blackberries on top and TMA on bottom, that's correct. So if 100 grams of blackberries give you 200 grams of TMA, and you could think if 50 grams of blackberry, that should give you 100 grams of TMA. You see that? Because we're in the same proportion, 1 to 2. So 70 grams of blackberries should give us somewhere between 200 and 100 TMA. And the only choice for that is G, 140. And if we did the math, cross multiply 70 times 200 divided by 100, you would get 140. Like if we did the cross multiplication for this proportion. But I showed you an equivalent proportion, so maybe you can ballpark it. 35. A total of how many jars was prepared in the experiment? A total of how many jars was prepared in the experiment? Okay. How will we know how many jars were prepared in the experiment? Each batch was equally proportioned into its 6 jars. How many batches? The scientists contained for determined. Okay. The scientists then made 9 batches of blackberry jam. So 9 batches of jam. Each batch used one of 3 types of pectin. Also, these are 9 batches. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then it says for each batch, 6 identical transparent jars were obtained. So that's 54. 9 times 6 is 54, which are all then capped and submerged in boiling water for 10 minutes. So that's 54 jars, 9 batches, 6 jars in each batch. How many total jars were prepared in the experiment? That would be 54. 9 times 6 is 54. Okay, moving along. Do you see how, and hopefully you can see how we move through those easier without the conflicting viewpoints. Conflicting viewpoints, like a reading passage, you got to kind of understand what's going on. Because reading comprehension here, you had to understand what was going on a little bit about the questions, but it was more about charts and graphs, right? Okay. 36. A little a and a little b can best be described as a little a and a little b. The table is based on a little a there. Frequency of a little a. Frequency of a little a. Let me look at my answer choices. A little a and best described as different versions of the same gene, different versions of different genes, identical versions of the same gene, identical versions of different genes. So we got to read what they talk about a little a and b. Researchers run study genetic drift over several generations of 8 populations of amoebas that produce asexually. Each amoeba in the initial generation of each population was homozygous for one of the alleles, A or B, of a specific gene. Each of 6 subsequent generations that may coming down was reproduced by randomly choosing half of the amoebas from the previous generation to reproduce. Figure 1 shows the frequency of allele A, and figure 2 shows the same for each B5. There were 10,000 amoebas in G. I don't know how we would know. This computer was run to study genetic drift, random fluctuations in allele frequencies over several generations of 8 populations of amoebas. Several generations of 8 populations that represented each amoeba in the initial generation of each population was homozygous. For one of the alleles, A or B, of a specific gene. Okay, so alleles A and B are of a specific gene. So they A and B are in the same gene because it's of a specific gene. So it's a different versions of the same gene, I would say F. Because it says each amoeba was in the initial generation of each population was homozygous for one of the alleles, A or B, of a specific gene. Right. And then because it's named A and when it's named B, I had to assume that those are different versions of a specific gene. It's homozygous for one of the alleles of a specific gene. So if these alleles belong to a specific gene, therefore allele A and B are described as different versions of the same gene. Yeah, I would say A, F. Based on what I just read, it may require background information. I may be messing up. This is 36. 36 is F, yeah. Yeah. So that's kind of, you just kind of read that, read what they said about A and B. That's what I did. You saw what I did. All right, suppose another population of amoebas with an initial allele A frequency of 0.5 and an initial size of 10,000 have been. So this is supposed. That means this didn't happen, so they're changing something. So with an initial allele A frequency of 0.5 and an initial size of 10,000 have been included in the computer simulation. Based on figure one, the frequency of allele B in G2 for that population will most likely have been close to what we found. All right, so allele A frequency 0.5, initial size 10,000. We're talking about figure one, right? Okay, so they said 0.5 and they said 10,000 or 10,000 amoebas in GL of each. Yeah, I don't understand what they're saying with that. I know 0.5, 10,000. The whole thing was done at 10,000. Or G, oh no, they said G0. There were 10,000 amoebas in G0 of each. There were, I guess it changed. Yeah, okay. So zero is here. This zero. That's they were 10,000 initially, and as you went, I guess we went on frequency of little A at 10,000. Oh, I should look at my answer choices. Based on one, the frequency of little B in G2 for the population most likely being close to 5. I would say 0.5 because if it's 0.5 for A, then the other 0.5 would be a B because they said it's either A or B. Homozygous one of the types of either A or B. So if it's not A, we assume it's B. If A has a frequency of 0.5, then B has the other 0.5 to make. So if A has a frequency of 0.5, that means half the time. That would probably mean that B would have the other frequency, so it would be 0.5. Let me see, 37. Let's see if that's B. They make you do a lot of reading for these. Yeah, 37 is B. That's all right. You gotta read and think, boy. This isn't easy stuff. So there used to be easier than this, if I remember right. Make you do a lot of reading and thinking. I guess it's not too bad. According to figure two, allele B was absent from which of P5, P8, and G2? P5 through P8 and G2. P5, P6, P7, P8. So that would mean that, yeah, when A is 1.0, that means that the frequency of A, if it's 1.0, that means it's only A. So that'd be in P5. So P5, frequency of 1.0, that means it's only A, it's nothing else in there. It's like a percentage. It's 1.0 is like 100%. So that's, yeah. kind of like what we explained in the last problem, how if whatever A is, B is the arrested part. So if A was 0.5, B would have to be 0.5. If A was 0.8, that's like an 80% frequency. B would have a 20% frequency, 0.20. So whatever is not A, it's B. So if we say we don't want B to show up at all, then it would have to be all A, which would be 100%, which is 1.0. And that was with the P5. F. All right, 39. Based on figures 1 and 2, is the effect of genetic drift on allele frequency greater in a relatively large population or in a relatively small population? So based on figures 1 and 2. Figures 1 and 2. Okay. Is the effect of genetic drift on allele frequency greater in a relatively large population or in a relatively small population? We don't know large or small. Let's look at the reasons though. This is a powerful question when the reasons can help you. I'm not gonna look at relatively large, relatively small. I'm gonna look at each of P1 through P4 experience greater fluctuations in the frequency of allele A than did each of P5 through P8. I don't think that's true. P5 through P8 experience greater fluctuations in frequency. Yeah, because see, look at this P5 through P8 is figure 2. Look at this chart. They're all over the place. It's a lot of fluctuations, right? But this chart, P1 through P4 is here. All of these are in the same area. It's not much fluctuation, right? So each of P1 through P4 experiences great fluctuation. That's not true. So the reason for A is wrong. So we know A is wrong. What about B? Each of P5 through P8 experience greater fluctuation. That's true. So B is a possible choice. What about choice C? Each of P1, P4 experience greater fluctuations. No. What about D? Each of P5 through P8 experience greater fluctuations. Yes. So now we know it's either B or D. And they also want us to pay attention to the fact that what? P5 through P8 experience greater fluctuations in frequency of allele A than did P1 through P4. Now, let's go back to the questions. Is the effect of genetic drift on allele frequency greater in a relatively large population? So that means P1 through P4 is relatively large or small, and then P5 through P8 is relatively large or small. Let's see. So there were 10,000 meters GO of each P1 through P4. There were 12 meters. Okay. So P1 through P4 had a large population, 10,000, where compared to 12 amoebas in the initial GO's initial generation of P5 through P8. So we know that we know it was either B or D. Is the effect of genetic drift on allele frequency greater in a relatively large population or in a relatively small? It would say relatively small, the effect of genetic drift on allele frequency, because you see it affected a lot more because of the fluctuations, that means that there was a greater effect, right? And on the P5 through P8, which had a much smaller population, right? Um, this one, P1 through P4, it wasn't a lot of fluctuation. So it wasn't much effect on the larger populations. So it's greater in relatively large populations or relatively small populations. The effect of the group would be greater on the relatively small. That's D. All right, number 40. Based on figure 1, in the initial generation of each of P1 through P4. Initial generation is G0, which is here. We read that up here. Right, I'm gonna read that. So initial generation GO right there. So initial generation, that's GO right here, and they said this table. They all started with a allele frequency of 0.5. Okay, what about that? Figure 1. In the initial generation of each of P1 through P4, how many amoebas had the genotype AA and how many amoebas had the genotype B? Where in the heck does B come from? Holy moly, good googly moogly. Well, 50-50, so I would probably say 50% because they say homozygous. Allele. Oh, a little A, yeah. It's 50-50. Because remember, we said it's either a little A or B, right? So if it's 0.5 in initial generation of a little a, that's 50% A. That means the other 50% is B. Half and half. And what was the population? There were 10,000 amoebas in the GO for P1 to P4. So half would be a little a, 5,000. Half would be a little b, 5,000. So that would be choice A, choice F. Which at the last two, 39 was D, 40 was F. It's funny, we struggle with some of those, and then you get the last one, and it's relatively easy. But you had to know that, yes, so 39, D, 40, F. You just had to know that background. Okay, so hopefully this was very helpful to you guys to give you explanations on the science section. We'll come back with videos on some of the other sections later. Thank you.